Hi. So this morning I would like to discuss about variation of parameters method. And the most important thing is you need to know that the general equation is a y double prime plus b y prime plus c y equals to fx. Okay, and then your fx is non-zero, therefore we can solve this kind of equation by using variation of parameters method. Okay, for variation of parameters method, since this method involve non-homogeneous, therefore the solution is y equals to yc, which is coming from the homogeneous solution. This one is a complementary solution. Okay, so next we plus with yp, y particular, where we need to consider the actual solution. Okay, so yc is yc, okay, but your yp is uy1 plus vy y2. Okay, as we discussed in class, we know that y1 and y2 comes from the homogeneous solution, where yc is ay1 plus by2. Okay, so y1 and y2 you can choose from the homogeneous solution, and then our u is given by the formula of negative integration of y2 fx over aw dx. Do not plus any constant here, and then v equals to y1 fx over aw dx. This w, okay, the w is your Wronskian coming from y1, okay, and then you have y2, the first derivative of your y1 and the first derivative of your y2, we just cross multiply, just like we want to find the determinant, right? So you get the Wronskian. After you get your Wronskian, substitute into this formula, and then you have y2 y1. Your a here comes from the general equation. Okay, so these are the formulas, and this is the solution of VPM. And now we want to discuss the first example. Okay, for the first question, okay, we have, okay, so we have y double prime plus 2y prime equals to x plus 1 e to x. Okay, so now we want to solve this one. We know that the solution to variation of parameters method is y equals to yc. Okay, y equals to yc plus yp. This is equals to yc plus uy1 plus vy2. First of all, find yc first by equating your fx to 0. So we have y double prime plus 2y prime equals to 0. Reduce this equation or transform this equation in the form of characteristic equation. So you have 2m. Okay, then only you can find the roots. Transform into the form of characteristic equation first. Okay, so m plus 2 equals to 0. Therefore, I have m equals to 0, and then m equals to negative 2. Since I have two different roots, this one, okay, two different roots, therefore the solution is yc equals to ae0x, which is a, plus be negative 2x. Okay, then I want to find uy1 plus vy2. U is coming from this formula, v from this formula. Okay, in order to fulfill this formula, I must find out what is my y2 fx aw, y1 fx aw. So I need to find out what is my y1 and y2. Okay, how to find y1 and y2? Y1 and y2 comes from here, ini dia. Okay, therefore I can conclude that A is A, therefore y1 is what? 0, 1. y1 is 1. Your y2 is A is A, the next to A is your y1. Your y1 here is 1 lah, not 0, okay? So your y2 is E negative 2x. Okay, so I want to find the Wronskian. Wronskian is given by this one. So y1, y2, what is y1? 1. y2 is E negative 2x. The first derivative of 1 is 0. The first derivative of this one is negative 2, E negative 2x. Okay, so you cross multiply, so you have this one and this one. So you have negative 2, E negative 2x minus this one. So you have 0. Therefore, your Wronskian is negative 2, E negative 2x. Okay, now I already found my Wronskian, and then I can find my u. U is given by, okay, negative y2 fx. What is y2 just now? y2 is this one. So E negative 2x multiplied by your fx. What is your fx? This one. This is your fx. So okay, I multiply with my fx, which is apa tadi? X plus 1. X plus 1 over e to x. Negative, integrate y2 fx. This is your fx over a is 1, w is negative 2, e negative 2 x dx. Where you can find your a here, a is 1 come from this one, ay double prime. Okay, ay double prime here. So your a is 1. Okay, so we try to simplify first and then we find the solution. I have e, pakai color lain lah. Okay, so e negative 2x is just the same as this one, cancel out. So I have negative, integrate x plus 1 over e to x dx. So you can bring e to x to your numerator. So you have integrate x plus 1 e negative to x dx. So here you have polynomial and then exponent, two different function, multiplication, you want to integrate, so we apply not product rule, okay? This one is tabular method, u dv, x plus 1, e negative 2x, okay? Differentiate again, so you have 1, integrate e negative 2x over negative 2, next 0, so you have e negative 2x over 4. Okay, so you have plus and minus. So this one becomes negative. This one times this one, so you have positive, negative, positive. So you have negative half x plus 1 e negative 2x. Okay, negative, positive, positive, so you have negative 1 over 4 e negative 2x. So done for your u. Okay, what about your v? V is given by y1. Where is a y1? y1 is 1. 1. Okay, this is my y1 multiplied by my fx. fx is x plus 1 over e to x, okay, multiply, over a, your Wronskian is -2, e -2x dx. Okay, so this one and this one, when you multiply this one, so you have e to the 0. E to the 0 is 1. Okay, so this one is -half. 1 over -2 is -half. Okay, so you have x plus 1 dx. So here I have -half x squared over 2 plus x. And finally, I have the solution of y equals to yc plus yp, which is uy1 plus vy2. So yc, apa yc kita tadi? So yc is a, okay, a plus be -2x, okay, and then next plus u. What is u? This one, u is negative half x plus 1 e -2x minus 1 over 4 e -2x. Okay, this one is u multiplied by your y1, which is 1, plus your v. Where is v? Okay, -half x squared over 2, okay, plus x multiplied by your y2. Y2 is e -2x. Okay, e -2x, and then you simplify. Okay, so this is how the method works, and this is the solution when you have second order linear differential equation with constant coefficient of this question by using variation of parameters method. Okay.